interfaces that allow smart contracts to interact with off-chain data sources. They act as the bridge between the blockchain and the external world, enabling smart contracts to access real-world information. So you might ask, what exactly are oracles, right? So oracles in the context of smart contracts are entities that provide external data to the blockchain. Smart contracts by design cannot access data outside their blockchain environment. Oracles serve as a bridge between the blockchain and the outside world, allowing smart contracts to interact with real world data and events. Move to the importance of oracles in smart contracts. Oracles enable smart contracts to access off-chain data such as price feeds, weather conditions, sport results, right? This capability will expand the use cases of smart contracts beyond the blockchain. So, an analogy we can use is the importance of oracles in smart contracts is like the importance of sensors in a smart home, providing real-time data to automate decisions. If you have a smart device at your home, it uses real-time data such as the surrounding noise to make automatic decisions. Oracles are like sensors in that smart machine, smart device, and basically what they do is essentially provide real-time data which helps in automating decisions. Okay. So what are the types of oracles? There are three types of oracles we'll cover today: inbound oracles, outbound oracles, and consensus-based oracles. So inbound oracles provide data from external sources to the blockchain. Outbound oracles send data from the blockchain to the external systems. Right? And finally, consensus-based oracles aggregate data from multiple sources to ensure accuracy. Okay, so let's set up the development environment. You must have already gone through the first two steps before, right? We have done this multiple times, but we are quickly recapping it. Install node.js and npm, right? First step in setting up development environment is to install node.js and npm. These are essential for running necessary tools and libraries. We have already done this. And then, as you know, we have to install Truffle, which is a popular development framework for Ethereum-based blockchains. You And you can do this by running the command npm install gtruffle. Next, you install Chainlink contracts, right? So, Chainlink contracts will provide the necessary interfaces and functions for integrating Chainlink oracles into our smart contracts. And we do this by running the command npm install @chainlink contract. You might have the question, what are Chainlink oracles? So Chainlink is a decentralized oracle network that enables smart contracts on various blockchains to securely interact with external data sources, APIs, and traditional banking systems. By providing reliable and tamper-proof data, Chainlink enhances the capabilities of smart contracts, allowing them to respond to real-world events and access data that exists outside of the blockchain. One of the key features of Chainlink oracles that it uses a network of independent node operators to fetch and verify data, reducing the risk of a single point of failure or manipulation. And they have high security and flexibility and also have cross-chain compatibility. Right? So, yeah, this is what is given. A Chainlink is a popular decentralized Oracle network that provides secure and reliable data feeds. That's what Chainlink ensures. Analogy to use is integrating Chainlink oracles is like hiring a trusted messenger service to bring accurate information. Well, let's go through the code example here. This will clear a lot of stuff for you. Okay, so yeah, again, Solidity version 0.8.0, right? Then your import statement imports the aggregator v3 interface from the Chainlink library. Interface defines functions and data structures that are used to interact with the Chainlink. Okay, next we have defined the contract, right? Price consumer v3. Okay, next is the state variable. Aggregator v3 interface defines a state variable price feed of type aggregator v3 interface. This will be used to interact with a specific Chainlink aggregator contract. Next is your constructor and defines the constructor function which is executed once the contract is employed, right? Okay. So now we have the statement price field is equal to aggregator v3 interface. And then you have a lot of numbers, right? Letters and numbers. So this initializes the price feed variable with the address. 0x8A95C 7B etc 1CC4. Address corresponds to a specific chain link aggregator on the ring by test network that provides the ETH slash USD price feed. Next is just a, and you have comment blocks also, right? So yeah, I hope this clears everything to you. Okay, continuation of this code is you have the function get latest price, right? So what this function does is it's a public view function that returns the latest price fetched from the Chainlink aggregator. Function body price feed dot latest round data calls a function latest round data from the price feed aggregator contract to variables round ID, price, started at, timestamp, and answered in round. Okay, return price returns the price variable which represents the latest price of Ethereum in USD as an int type. So a summary of this entire thing was to fetch the latest EHT USD price from a specific Chainlink aggregator on the RingPi network. It imports the necessary interface, initializes the Chainlink aggregator, right, and the address, and provides a get latest price function to retrieve and return the latest price. Okay. Next, what we'll cover is how to write a smart contract with Oracle integration. Now that we have a solid understanding of oracles and their importance, let's dive into the process of integrating an oracle into a smart contract. We'll explore a step-by-step approach to incorporating an oracle into your contract, ensuring what's the goal of oracle? Reliable and secure data feeds. Okay, so the explanation of oracle integration, right? So when you write a smart contract which has oracle integration, it's like setting up a system to send requests to a weather service and receive updates. This involves setting up a request. Like if you want weather updates, you need a request, right? That I should get weather updates. And you have to know how to handle the response that when the weather updates, how do you that when the weather updates come, how do you handle them? So this process of requesting and receiving data from an oracle in a smart contract is similar to how a weather app on your phone sends a request to a weather service and displays the updated forecast. It's simple, right? You must have seen the weather app on your phone. Everyone sees it. Temperature right now is 25 degrees. Keeps updating, right? The requests are sent multiple times. Like periodically, every 10 minutes, you'll see there'll be a different weather 24 degrees, 27 degrees, rain expected. So a request is sent and it's received also. So first you need to set up the request to the Oracle, specifying the data you want to receive. That I want to receive the weather update, temperature, right? Is it going to rain? What's the humidity? Anything. Any external data that your smart contract needs. Okay, so once the request is made, the Oracle will process the request and send the data back to your smart contract. Smart contract then needs to handle the response from the Oracle, verifying the data and using it in the contract's log. Okay, so the code example is weatheroracle.solve. So this code example demonstrates the implementation of a weather oracle contract that integrates the Chainlink Oracle network to retrieve temperature data for a given location. Contract inherits from the Chainlink contract, which provides the necessary functionality to interact with the Chainlink oracles. Has state variables such as temperature, which will store temperature data, oracle address, job ID, and fee required for the Chainlink request. We have two functions, the request temperature data function, right, and the fulfill function. The request temperature data function is used to initiate a chain link request for temperature data, takes a location parameter, and returns a request ID. The fulfill function is the callback function that will be called by the Chainlink oracle. When the temperature data is available, it updates the temperature state variable with the received data. Okay, so this won't be very clear to you obviously, but here I'll explain everything in the code example. So I've taken examples also. I had a little bit of the code is cut off in this diagram. I'll try my very best to explain it, right? So in the first section, we are importing libraries, right? So this contract is importing the necessary Chainlink client library and interfaces like Chainlink client.sol, interface Chainlink request interface.sol. interface chainlink.sol, interface link token interface.sol, right? Yeah. Next are the variables, essentially temperature, public variable to store temperature data, oracle, address of the chainlink oracle to be used, job ID, the unique job ID associated with the chainlink oracle request, the amount of link tokens to be paid for the oracle request. And the constructor sets the public chainlink token address, initializes oracle job ID and fee variables with appropriate values. So I hope this is understandable. That's what the constructor does. And basically you have to replace it with the actual ones. I have just given sample ones for the time being in the code. Okay. Next is our function request temperature data. Right. So it's responsible for building and sending the Chainlink Oracle request. Takes a location parameter to specify the location for which to fetch the temperature for, and it creates a Chainlink request and sends it to the Oracle. And next is the fulfill function, right? The callback function called by the Chainlink Oracle when the temperature data is available. It updates the temperature variable with the received data. So remember to replace placeholders like Oracle address, job ID, and your API key with actual values specific to your Chainlink setup and API provider. This code might be a little difficult to grasp, but I have tried my best to explain it with my knowledge, right? So just remember these are the requests you have to add and all, etc. Okay. So let's move to handling Oracle responses. We handle the Oracle response by defining a callback function that processes the data received from the Oracle, like setting up an automated system to process the information received from the messenger. The callback function will be responsible for taking the data from the Oracle and incorporating it into the smart contracts logic. So yeah, next is essentially we are going through handling Oracle responses, right? So the fulfill function was responsible for doing this. When the Oracle sends back the requested temperature data, this function is called to store the temperature value in the temperature variable. It takes two parameters, request ID and temperature. Request ID parameter is used to verify that the response is for the correct request, and the temperature parameter contains the actual temperature data returned by the Oracle. The record chainlink fulfillment modifier is used to ensure that the function can only be called by the chainlink oracle, preventing unauthorized access. Helps to maintain the integrity of the oracle integration and ensure, right, that the data received is trustworthy. And after the temperature data is received and stored in the temperature variable, it can use the value in its logic, such as triggering actions based on the temperature or providing temperature data to other parts of the application. You can do anything with it, right? Once you have received and stored it. So we'll go through again examples of using oracles in a smart contract, right? So using an oracle in a smart contract is like incorporating real-time data into an automated system to make informed decisions. So the comprehensive example we took is the same one as I showed you. I'll go through it again if necessary. I don't think that should be necessary. The comprehensive example was the same code I showed you earlier, right? You have a smart contract called weatheroracle.sol and you're integrating Chainlink Oracle to it. So this fetches temperature data from an external API and stores it on the blockchain, right? So this is what you're doing. It will import the necessary Chainlink client library, inherits from the Chainlink client contract. The contract defines the following variables: temperature, Oracle, job ID, and fee. Constructor is there, it sets the public Chainlink token address and initializes the Oracle job ID and fee variables. The request temperature data function is responsible for building and sending the Chainlink Oracle request, right? Fulfill function, as I explained, right? Called by when the called when the temperature data is available. So next we'll go through deployment script, right? So the deployment script for the weather Oracle contract is located in the migrations to underscore deploy contracts.javascript file. This uses the Truffle framework to deploy the weather Oracle contract to the Ethereum blockchain. It simply imports the weather Oracle contract, then calls the deployer.deploy method to deploy the contract. This ensures that the weather contract available that the Weather Oracle contract is available for use in a smart contract. Deployment script, right? We have done this previously. You have already learned what migrations are. So it's the same thing. We are doing it again here. So now we'll get to interacting with the contract. So in the following slide, I'll show you the code about how to interact with the deployed Weather Oracle smart contract using the web3.js library. Right, so a basic before I go through the code will start by importing the Web3 library and creating a new instance of the Web3 object connected to the Ring by Ethereum test network using an Infura project ID. I've already done this. Contracts ABI, as you already know, application binary interface, and address are then defined, and a new contract instance is created using the web3.eth.contract method. Get temperature function is defined, sends a transaction to the request temperature data method of the contract. This retrieves the user's Ethereum accounts and sends the transaction from the first account. Check temperature function is defined, which calls temperature method, retrieve the current temperature value. And finally, the code calls the get temperature function with the location New York and the check temperature function to demonstrate the interaction with the contract. So here's the code for you. Right. So it might be a bit messy and I apologize for that, but I've tried my best to get the code into the video, right? So if you want, I can give you a simple explanation of this code. So you import the Web3 library as I told, then you create an instance of the Web3 object, right? Connected to the Ring by Ethereum test using an Fura project ID. Next, you're defining the ABI of the project, right? In a smart contract. So the ABI specifies the methods and events of the contract. Next is your contract address, right? So this statement we are here, const contact address 0x your contact address. You're specifying the address of the deployed Weather Oracle smart contract on the Ethereum network, and you replace 0x your contact address with the actual contact address, right? Next, you're creating a contract instance. So So this statement const weather oracle equal to new web3.eth.contract ABI contract address. It creates a new instance of the weather oracle contract using the ABI and the contract address. Next, what you're doing is requesting temperature data. This uh, it defines the get temperature function, which takes a location as an argument. It retrieves the user's Ethereum accounts and sends a transaction to the request temperature data method of the contract. Right. Next, what you're doing is you're checking current temperature, right? Using the check temperature function. So essentially what you're doing is you're retrieving the current temperature value and then it's not visible on the state, but you will obviously have your main function where I will write async function main, await get temperature of New York and await check temperature, which has no parameters, right? So your main function's there. I did not have place to fit it in this page, so I skipped it, but please remember there's a main function part. So that's it, I guess. A summary of this would be a recap of key points is the oracles act as a bridge between the blockchain and the external world. They enable smart contracts to access off-chain data, expanding their use cases. Different types of oracles serve different purposes. And integrating the Chainlink oracles involves setting up the development environment, writing the smart contract, and handling oracle responses. And finally, an interactive exercise or quiz for you, right? So you'll be tasked with setting up a development environment with Node.js, NPM, Truffle, Chainlink, basically everything we have done yet, right? Then you'll write a smart contract that integrates with the Chainlink Oracle to fetch external data. Then you will deploy the contract to a testnet. You will write a script to interact with the deployed contract and request data from Oracle. Finally, you will verify the Oracle response and check the data stored in the contract. Right? So the key steps are given here. You set up a development environment. You develop a smart contract that uses Chainlink Oracle. You deploy it in a testnet. You write a script to interact with the deployed contract. And you verify the Oracle response. You verify the Oracle response by checking the data stored in the contract. You get hands-on experience with integrating Chainlink Oracles into your smart contracts, and you'll also learn how to effectively interact and utilize external data sources in your decentralized application. That's it for today. Thank you very much, and I'll see you on the next one.